This video intends to explain how to read Florida product approval drawings for window and door systems, in particular, the installation instructions associated with those approved products. So it might be helpful if we could recognize what information can we expect to find. Florida Statute 553.842 provides that the Florida Building Commission shall adopt rules under other statutes to develop and implement a product evaluation and approval system that applies statewide to operate in coordination with the Florida Building Code. In fact, the Florida Building Commission did adopt Rule 61G20-3.005 to deal with the product approval process. That rule provides two methods by which products can demonstrate their compliance with the Florida Building Code. Two of the methods, which pertain to window and door systems, rely on evaluation reports. Section 4 identifies evaluation report and test report documentation requirements. It identifies that all reports and documentation required in subsections for methods 1 and 2 shall contain the information listed below. This section identifies that installation instructions for windows, including attachment, at a minimum shall include the following: type and grade of anchor and/or manufacturer's anchor specifications, including minimum nominal size, minimum penetration into substrate, and minimum edge distances. Type, physical dimensions, material, and grade of any accessory item or strap, if applicable. Spacing of anchors, shims, accessory items, and straps. Illustrated diagrams of the attachment of the product to the structure. When we go to the approved products website, we find with the approved product a record of the evaluation reports and the installation instructions. Summing all of that up, we expect to find what kind of fasteners do we use. We expect to see the dimensions and accessory profiles that are used in the product itself. We expect to see the spacing of anchors so we know where they should be when the product is correctly installed. So items number 1 through 3 are going to be plain old written descriptions of the things that make up this product. And finally, we should have illustrated diagrams that show the attachment, how the product is oriented and arranged with respect to the substrates that surround it. Item 4 is going to be a drawing, and what we're going to see is a bunch of little lines pointing to different parts of the drawing, and those lines are going to tie back to the descriptions of the different elements of the product itself. This is an example set of installation instructions that is for the Resistor 3300 series system by Trulight. Trulight has done a really excellent job of creating their product approval documents, and so we want to take a look at them. This system in particular, it's a very complicated system. There's a lot of parts and pieces and different ways it can be configured, and so this provides us with a good example. But the purpose of this video is how to read these drawings, not to read you a specific drawing, okay? And so let's just recognize, okay, the composition of the information here. Okay, we have a series of pages, right? On each page, we're going to see a sidebar which contains information. In this case, it identifies the manufacturer, Trulight, the 3300 series system, the engineers associated with this, the product approval number, and in the bottom right, this is very important, we have a page number, okay, basically drawing number 1 of 19 total drawing sheets, okay? Now that's very important because we're looking at a drawing, a two-dimensional drawing. It's a drawing of a three-dimensional thing. 2D, 3D, they're totally different. How do we represent our 3D objects in a drawing that's only 2 dimensions? What we do is we have a drawing from 2 different perspectives, okay? So this perspective is standing and looking at something. And you can see this drawing shows a pair of doors in the middle. They have little sideways slashes to indicate that there's supposed to be glass there. And then you have some vertical elements, and then you have horizontal elements. Looks like window framing. That's what it's intended to represent. And you have these clusters of screw fasteners, little lines, 4 lines with a circle around them. Now you'll notice there are symbols all over this drawing. The symbol is a black triangle with a white circle on top of it so that you can't see most of the triangle. And then that symbol has, extending from the triangle, it has a little black line, and that black line doesn't extend out a very far distance. Now that's a symbol that's telling us there's another drawing that corresponds to the location of that black line, and it's drawn from the perspective looking in the direction that that black triangle is pointing. So right on top of the doors, we have B1 on the top of the circle and 13 in the bottom of the circle. B1 is going to be the drawing, the detailed number, and 13 is going to be our sheet 13. And what we're going to see, where that black line extends, we're going to see a drawing of that part of the system, and it's going to show us the top of a door and the metal frame member that goes on top of that door. We go to sheet number 13, and right there in the middle we see drawing B1. Now that shows us, it looks like a door kind of cut through like a two-dimensional, right, like a microscope type slide of a door, the top of a door, and then it appears to have a metal element on top of it with glass in it. Okay, so what this perspective is showing us is it's showing us the sideways view. If you're looking in the direction that that black triangle is pointing to the left, and that line that extends downward from the black triangle, it crosses through the top of the door header and through the top of the door. That's what we see here. If we're looking toward the left, we see that the door, it's on the outside, and then it's got the metal above it. And we see a whole bunch more symbols. There are symbols everywhere. To the left side of the door, you can see at the top we have F14, F2, G, G1, okay? And these are on sheets, F on sheet 14, and so on. There are a lot of different symbols throughout this entire drawing. That's because they have a lot of different components available that can be used for this system. And each one of those components is going to be represented with its own drawing that identifies what are the parts, how is it put together. And when we look at this drawing, we see, for example, to the left side of the door, you see a series of 5 symbols that are associated with the left door jamb. The top symbol is F14, so that's going to correspond to sheet 14. And you can see here F on sheet 14, door jamb mullion at transom. F2 on 15. And you can see here on sheet 15, detail F2, we have the condition where the frame is above the transom. You might notice that it has this screw applied sash. You see the little screw, and there's a line extending from it. It says number 10 by 1/4 inch FH flathead self-machining screw. That's where those items 1 through 3, they're written descriptions of what is included. And you'll notice that this drawing, there's no door here. That's because you look at the location of the black line extending from that detail marker F215. It's above where the door is. Okay, it's above the door. Now G14, it looks like that line extends into the door. Sure enough, there's a door. Now, of course, we're very interested in what are the anchor conditions. So you can see in the bottom right of the diagram C13 and C13.1. C13 shows us the bottom member of the frame, and there's a screw which says there's a line extending from the screw. It says typical anchors C elevation for spacing. ELEV is an abbreviation for elevation. And we get the same thing on C13.1. But you know what? There's a difference between these two, C13 and C13.1. It's not readily apparent at first, but on C13.1, we have part number 1C, okay? And that's pointing to the main frame profile. Now this profile has two screw splines. If we go back to sheet 13, we could see it's part number 1 pointing to the main frame element in detail C13. And that frame element has 4 screw spline screws. So there are different frame members that are being used at the sill, which is totally fine because they're both called out and they're both included in the approved product instructions. So these are both valid to be used. That's why you have so many different details here that appear to call out the same part of the frame. Really, they're calling out different profiles and different options that can be used in different cases. Okay, so you link together the 2D drawings in a way that you can create in your mind, at least, an understanding of how that 3D object should be. It's two drawings that are at 90-degree perspectives to each other, and that's what allows us to formulate this 3D perspective of the objects that are represented by these drawings. Now, as for the rest of it, you just simply read it. And the point of this video, it's not to read all of this stuff to you, but I just explained how you navigate with two-dimensional drawings and connect them to make a three-dimensional thing. And you can see throughout the different pages of this approval similar drawings, and you can see how the different parts of those drawings are all labeled and it's called out what they are, and it says, you know, in plain written language what it is that is being identified and used, and you can see how those things are arranged relative to each other. We also have maximum glass capacities, you know, this is shown to us in a table, and it says what is the maximum width and what is the maximum height. It's a question of just reading it, you know, and we have the different Mullion profiles and what their properties are and their dimensions. And finally, we have a table of the accessory items that are used to create the window system. These all have item numbers, and those item numbers are going to correspond with the different drawings, dimension drawings, and the details which show the frame members and all the parts, they're all called out with these numbers. These numbers correspond to that table of items. And we have detailed drawings that show how the product is oriented and attached to the structure.